Good morning to you all. So in our previous session, we started to talk about the structure of universe, the sun, planets, stars, and the galaxies. We learned a lot yesterday, so that's why I want to revise some of the subjects that we learned, and we will learn some different concepts also, a little bit more different concepts, and then we will solve some questions in order to practice. So let's start with revising our place in the universe. So Earth is one of the 8 planets in the solar system, and it is the 3rd planet from the Sun. We are orbiting around the Sun, and we are using the energy which is coming from the sun on Earth, right? The life on the Earth is all connected with the sun's energy, because plants are using this energy day and night. It's happening with the sun's light, etc. So with us in the solar system, we have 8 different planets. So a solar system is made up of stars and other objects who are orbiting around these stars. So our solar system includes only one star, which is Sun, and its family of orbiting planets, moons, and other matter such as gas and dust are all part of this solar system. Okay, so with Earth, Sun has also 7 different planets we discussed yesterday: terrestrial planets and gas giants. We have different classification. We have dwarf planets, we have asteroids, meteoroids. A lot of all these are spinning around the Sun by its gravity, basically. So after solar system, bigger than solar system, what we have galaxies. So a galaxy can have billions of stars. Okay, our galaxy is Milky Way, and in this Milky Way galaxy we know that we have a lot of stars like Sun, and we have some stars bigger than Sun, we have some stars smaller than Sun or brighter than Sun. But imagine that, like I always say to you, imagine that you are looking at the night sky and you are seeing all these stars, and just please also remember that not all of them are from our galaxy Milky Way. Also we are able to see different galaxies, we are able to see different stars from different galaxies. So they are basically the building blocks of the universe, because all the galaxies are coming together and forming the universe. So we don't know everything about the universe because it is so vast and big. And it is really hard for us to observe outer space with the technology we have. And astronomers estimate that there are between 100 billion or trillion galaxies in the universe. So we said that we have a solar system. Like our solar system, we said in a galaxy there may be billions of different stars, and we say that now we are saying that in a universe, we have one universe. In universe we have trillions of different galaxies. So it may help you to imagine how big the space is. So what we learned yesterday related with this topic, actually it was basically revised up to now. I just want to focus this sizes quickly in order to again just make sure that you are understanding how big is the universe is. On Earth, we have the diameter of Earth is 12,000 kilometers, more than 12,000 kilometers. It is like the width of 3 times bigger than the width of continental USA. So it is really big. So we can understand the size of Earth. So the Sun is higher, bigger than 100 times of Earth. So it is saying that 109 Earths would fit across the Sun. So we were thinking the Earth is big, but now it is the Sun is bigger. So for example, our solar system. In our solar system, it is so big that more than 7,000 suns would fit inside our solar system. So the space is not packed together. There are a lot of big, vast, empty areas. Okay, so and the Sun, like I said, we have in our solar system we have place for more than 7,000 suns, and a galaxy is bigger than, wider than, more than 880 million times of our solar system. So we were thinking that Earth is big, Sun is bigger, but now we have something called as solar system, something called as galaxy. So imagine that in the universe we have billions, trillions of galaxies. So this is how big the universe is, basically. So we have something called as light year when we are talking about the distances in the space. So remember what we were talking of just previously. I was saying that we have a lot of empty space in the universe, in the solar system, and they are really far away from each other. The planets are really far away from each other. We are really far away from the Sun. So the normal distance measurements like meters, kilometers are not working appropriately in the space. We need something bigger. So that's why we have something called as light year. So when you first, this is really important. When you first see this light year, you may think that light year is a measurement of time. It is just measuring the time, maybe. But no, it is the measurement of a distance. Light year is giving us the total distance that light travels through space in 1 year. Light is the fastest traveling thing, as we know, and we can measure. So, and it is, the light travels through space at about 300,000 kilometers per second. In 1 second, light can travel 300,000 kilometers. Okay, it's a lot of distance. So, or 9.5 trillion kilometers in 1 year, we can say that. But you may have seen this version more in every field of science. So what does it mean, light year? If I know that how much distance light is taking in 1 year, a light year is basically equal to the 9.5 trillion kilometers. So in space we are using light year as a measurement for distances. For example, between this distance towards Sun to Earth, it is not that much big when it compared in the light years, because the light which is coming from sun to the earth, it is only taking 8 minutes. In 8 minutes, light can travel all this space. Okay? So earth is 8 light minutes away from the sun. This means it takes 8 minutes for sun rays to come to earth. So a light year is the distance that light can travel in 1 year. So if it 8 minutes it is coming to the earth, in 1 year it will come towards like 9.5 trillion kilometers away. Okay, so I hope it is more helpful for you to understand the light year. So in order to make it more clear, for example, the Andromeda galaxy is the nearest galaxy to our galaxy. Okay, it's our neighbor galaxy. But even this galaxy, we are saying that it is the closest one, and it is 2.5 million light years away. What does it mean? Even if we were able to go somewhere as fast as light, okay, even we have a speed as fast as light, it will take 2.5 million years to go Andromeda galaxy. Okay, or our nearest star to us is 4.2 light years away. So if we are able to have the speed as light, it will take 4.2 years to go the nearest star. But we don't. Almost all the spacecraft, contemporary spacecrafts, travel about 10,000 times slower than light. It is really highly unlikely to reach the speed of light, basically. And with this speed, it will take 42,000 years to reach even the nearest star. So now please imagine the stars that you see on the sky. You are seeing the light which is coming from these stars. But imagine how long this light is, how long it takes from that star to this light is coming from there to here, to you on Earth. Even our nearest star, even we will be able to see the light of our nearest star after 4 years. Okay? After 4 years. From sun, in 8 minutes light is coming to the Earth. But from the nearest star, the light is coming in 4 years to the Earth. So we have a lot of stars in the sky, and they are even further away from us. So let's try to solve this question related with stars in order to make a quick revision. What is a star? Click all correct answers. So we may have more than one correct answer. We can say that stars are composed of gas. It is correct. They are emitting light or other electromagnetic radiation. It is correct. It is a large celestial body. Yes, stars are pretty large. Almost all of them larger than Earth. And a large body composed of a rocky crust. So even in the crust of a star, we have gas actually. That's why it is not correct. We will learn more about stars in the next session. So, just for closing this topic, I want to solve this question. So a typical star, what can be a typical star between these options? Obviously sun. So like I said before, you can just pause the video and try to find your own solution, own answers, then just correct them with me. Okay, so space and all the matter and energy inside this place, what is it? Basically the universe. None of these are applying, can have all the energy and matter, but the universe has all the energy and matter. Collection of stars, gas and dust. What can be a collection of stars, gas and dust? A galaxy, obviously. So a star and objects orbiting around it. What we call this? If we are talking about a star and the objects around it, we are talking about a solar system, like our solar system. And we have two different types of planets. We have gas giants and we have terrestrial planets. And Earth, Mercury, Venus and Mars are terrestrial planets. On the other hand, Jupiter, Saturn, Uranus, Neptune are gas giants. Okay, well done. So please, if you want to revise this lesson, please refer to Module G, Unit 1 and Structure of the Universe, or you can use the PDF files that I will be uploading this week. Okay, so if you can check your book, it will be amazing, but if you don't, still you can use these videos and these PDFs. I hope you enjoyed what we learned today. See you in the next session. Thank you.